Hello, my Algebra 2 kids. I've missed you guys, and I'm still missing you guys because I am talking to an iPad instead of talking to you guys in person. But we're going to continue on, and we're going to try and get through this chapter 8. So, welcome back from spring break, and today we are picking up in lesson 8.5. So, for period 3, this will be your Wednesday assignment, and it will be due the following Wednesday. For period 6 and 7, this will be your Friday assignment, and it will be due the following Friday. Okay, so we are looking at lesson 8.5, which is adding and subtracting rational expressions. So rational expressions being fractions that have variables in them. So first things first, in order to add or subtract rational fractions, what has to happen? Or let me rephrase this. In order to add and subtract fractions, what has to happen? And hopefully you remember that we have to have common denominators. That's going to be the name of the game today, is getting that common denominator. Now, as you look at this, kind of a crazy looking example here. I get it. But as you look at this example, you'll notice there's two fractions here that are ready to be added. And you'll notice as you look at those two fractions that they do not have the same denominator. And so one of the first big things we're going to have to make sure we're doing is that when we are getting a common denominator, that we start by factoring our denominators. And so if you factor the first denominator, there's a GCF of x, and that factors into x times x plus 3. If you factor the second denominator, factors into x plus 3 and x plus 3. A common denominator here in this situation is going to be anything that overlaps and then any leftovers. So as you look at these two denominators here, there is an x plus 3 that overlaps. So there's one x plus 3 from the overlapping. If you look at the first denominator, there's an x, so we have to have the x there. If you look at the second denominator, there's two x plus 3s, so we have to have a second x plus 3. I'll go into that in more detail as we look at some of our problems. But I want to real quick just kind of do a review. And as we do a review here, do you remember how to add something basic, such as 1/2 plus 2/5? In order to add 1/2 plus 2/5, we need a common denominator. A common denominator there would be 10, because 2 times 5 is 10. How do we get those numerators? And this is what I want to review real quick. How do we get this denominator of 2 to become a denominator of 10? And that is, you multiply by 5. If you multiply that denominator by 5, you're going to multiply the numerator by 5. And 1 times 5 is 5. On the second one, how do we get the 5 to become the 10? 5 times 2 is 10. So what do we do in the numerator? Multiply by 2, and 2 times 2 is 4. And then when we add those, 5/10 plus 4/10 is equal to 9/10, because you add the 5 and 4, keep the denominator of 10. Okay, does that sound familiar? That is my goal there, to sound familiar. Basic adding, subtracting fractions that you've been doing, since late elementary. Okay, so let's look at example 1. Example 1 is all about adding rational expressions. I'm basically going to do 2 examples from each section. 2 adding, 2 subtracting, and then on the back we'll talk about doing 2 complex fractions. So, as we look at example A, what is the sum of each of the following in simplest form? And then the directions also say to state any restrictions on the variable, which we'll talk about. So, as we look at A, we have a denominator of x minus 1 and a denominator of x squared minus x. So, are those the same denominator? The answer is no, so we need to get a common denominator. Hopefully you remember up from the original problem, in order to get that common denominator, you need to start by factoring. So, the first denominator of x minus 1 is already factored. Not a big deal. X squared minus x, we need to factor that. If you think about x squared minus x, both terms have an x in common. So we're going to factor out a GCF of x. If I factor out a GCF of x squared divided by x is x, minus x divided by x is 1. So that x squared minus x can now be replaced with the denominator of x minus 1. Okay, so now my first denominator is x minus 1. My second denominator is x times x minus 1. We need a common denominator. So as I set up to get my common denominator, first of all, what do these fractions have in common? And you'll notice they both have an x minus 1 in common. So x minus 1 is part of our denominator. Now, any leftover pieces, as we look at the first fraction, it just has x minus 1, so that's good. As we look at the second fraction, there is also an x. So my common denominator is going to be x times x minus 1, because that takes everything that's in common and uses it once, and then any leftovers. Okay, so as we look at this, how do you get this first denominator of x minus 1 to become our new denominator of x times x minus 1? So what is that denominator missing? It's missing an x. So we're going to multiply this first fraction by x in the denominator. If we multiply the denominator by x, you know it, right? We have to multiply the numerator by x. And so that means on top, I am going to have x times x plus 1. You can go ahead and multiply that out right there if you want, or you can wait and do it next step with me. The second fraction already had a denominator of x minus 1, so our numerator just stays the same and carries along, and that is a negative 2. So since we're going to be adding these two fractions together, we want to multiply what our numerator of the first fraction. So I'm going to multiply, or distribute, should I say, x times x and x times the 1. So as I multiply that, x times x is x squared, plus x times 1 is x. Now, if we're adding these fractions, remember you add the numerator, keep the common denominator. So then it's plus a negative 2. Well, plus negative 2 is the same as writing minus 2. That's your numerators added together. My common denominator, I just carry along. So I'm carrying along an x minus 1. Now, the denominator, I do not usually multiply together because we want to look for canceling opportunities. As we check this one out, my numerator is added together. The question becomes, can it factor? And if it can factor, you want to factor in case there are any terms that will cancel, or any factors that will cancel. So as we look at that numerator, x squared plus x minus 2. Can that factor? And if it can factor, it would be factoring into two parentheses. So let's give it a shot here. It would factor into two parentheses, such as x squared breaks into x times x. What multiplies to be negative 2 and adds to be 1. So if it multiplies to be 2 of any sort, it's 1 times 2. If it multiplies to be negative, I need a positive and a negative. If it adds to be positive 1, positive 2 minus 1. My denominator I'm carrying along as x minus 1. Okay, was that worth factoring? Does anything cancel? And hopefully you'll notice that if we recall from what we learned in, was it lesson 8.4, I think? There is some canceling in that the x minus 1s can cancel. So the x minus 1s cancel. On top, I'm left with an x plus 2. In the denominator, I'm left with an x. Okay. Do you remember from before spring break? Can those x's cancel? The answer is no, because this x on top is added to 2. So, right there, final answer of x plus 2 over x. Now, don't let it get away from you. Don't forget, we also need to state any restrictions on the variable. So, if you flip back to, I believe it was lesson 8.4, we talked then about finding restrictions on the variable. And restrictions on the variable are there any values that would make that denominator equal to 0? And if there are, they can't be allowed values. So remember, in order to do this, we start by setting the denominator equal to 0. And look at your common denominator and use the factored pieces. So we would be setting x equal to 0 and x minus 1 equal to 0. If you solve each of those, we would know that x cannot equal 0, and when you do x minus 1, you add the 1 over, x cannot equal 1. So we would have restrictions on the variable that x cannot equal 0 and 1. Okay, there's restrictions on the variable, and there's our first adding problem. Okay, if there's questions, hopefully you can hang with me, and we will, as we go through more examples, maybe some of the questions will get sorted out, I'm hoping. So let's look at example B. Example B is x over x squared minus 4 plus 1 over x plus 2. Do they already have a common denominator? The answer is no. Now keep in mind, could some in homework already have a common denominator? They could. Don't let those be tricky for you. Okay, since we do not have a common denominator, remember we need to look and make sure everything is factored. Does x squared minus 4 factor? Yes, it does. It's the difference of squares. It factors into 2 parentheses. X squared breaks into x times x. Square root of 4 is 2, so 2 times 2. And since it multiplies to be negative 4, we're going to use a plus and a minus. So that x squared minus 4 factors into x plus 2 times x minus 2. Okay, so I'm going to draw my empty fraction bars here. And as I mentioned earlier, I'm not going to plan to do C, so if you run over into C, that's okay. Okay, common denominator. What is in common? And so as we look at factors in common, both fractions have a factor of x plus 2. Are there any leftover pieces? As we look at leftover pieces, that first fraction has a leftover piece of x minus 2. Are all of the pieces accounted for? And they are. So that makes our common denominator x plus 2 times x minus 2. Okay, so first fraction, common denominator is already the existing denominator, so the x on top just carries down. Second denominator does not have the common denominator. What is missing? It currently has an x plus 2. What factor is missing? And that is the factor x minus 2. So if we multiply the denominator by x minus 2, remember, you multiply the numerator by x minus 2. And so, on top of that second fraction, you multiply 1 times x minus 2, and 1 times x minus 2 is x minus 2. We have a common denominator now, so I'm ready to add my fractions. Remember, my denominator is the same, so I'm just going to write it in x plus 2 times x minus 2. My numerators, I just add. So I'm adding x plus x And 1x plus 1x is 2x. And then it's plus a minus 2. So I'm going to write it as 2x minus 2. Okay. Is there anything that can cancel? In order to decide for sure, I always recommend you do any factoring you can in the numerator. Does 2x minus 2 factor? And do you notice there's a 2 in common? So if I factor out a GCF of 2, 2x divided by 2 is x, minus 2 divided by 2 is 1. All over x plus 2 times x minus 1. Excuse me, that's supposed to be x plus 2 and x minus 2. Okay, now, are there any factors that cancel? And as you'll notice, none of the factors are identical matching. So, nothing cancels in this particular case. So my answer is right there. 2 times x minus 1 over x plus 2 times x minus 2. Now that does bring the question, could we leave our last answer, this answer right here, as a final answer? And for me, yes you can. Math Excel, it will depend on what they're asking. But for me, I would accept either of these last two answers. Okay, and lastly, restrictions on the variable. Remember to get your restrictions on the variable, set your denominators equal to 0. So what kind of denominators do I have that need set equal to 0? And that is the x plus 2 equals 0 and x minus 2 equals 0. If we solve both of those, we learn that x cannot equal negative 2 or positive 2. Or what I'm actually going to write is x cannot equal plus or minus 2. Okay, that was adding. Now we're ready for subtracting. Good news, if you want to look at it as such, subtracting is just the same. There's just a subtracting sign in the middle. So you just have to watch out and make sure you subtract everything in the second fraction. But other than that, it's just the same type stuff. So, find each of the following differences, state any restrictions on the variable. So, as we look at example A, do I have a common denominator? Answer is no. So since I don't have a common denominator, let's get those factored. Does x squared minus 2x factor? And it does factor. There's a GCF of x, so I can factor that into x. If I divide out x, I'm left with x minus 2. Second denominator, can it factor? And it can. This time there's a GCF of 2. Factor out the 2, divide by 2, we're left with x minus 2. Okay, so question becomes, what is my common denominator? So what is in common, first of all? Both fractions have in their denominator n x minus 2. So that has to go in my denominator. If there's nothing else in common, look for leftovers. What are the leftover pieces? The first fraction has an x. The second fraction has a 2. So in my common denominator, I need a 2 and an x, or what I'm going to write, 2x. So my least common denominator is 2x times x minus 2. And that's what I'm looking for. So, first fraction. Compare. How do I make x times x minus 2 look like 2x times x minus 2? And that is to multiply by 2. If I multiply the denominator by 2, we multiply the numerator by 2. So how do we multiply 2 times x plus 2? We're going to distribute, right? So I'm going to go ahead and distribute if you can handle that. 2 times x plus 2. 2 times x is 2x. Plus 2 times 2 is 4. You will notice that what did I write in between my fractions? And this time I wrote that it is a minus. So beware when problems and homework are mixed together that you watch out for the subtractions. Second fraction. What is my denominator missing? Has the 2 and the x minus 2, it's missing the x. If I multiply the denominator by an x, multiply the numerator by an x. Same thing, I'm going to take that x and I'm going to distribute. X times x is x squared plus 2 times x is 2x. Okay, we have our common denominator, right? So as I have my common denominator, I'm ready to combine my fractions. Common denominator is 2x times x minus 2. Okay, as I start subtracting, look for like terms here. I've got 2x goes with 2x because it's subtraction. 2x minus 2x will cancel. I've got a 4. No other whole numbers, so 4 just carries down. I've got a minus sign. And I've got an x squared. Okay, as we look at that numerator, 4 minus x squared. That is backwards from what we often look at. My suggestion here is that you think about reversing that. And I always encourage you to have the variable out front. And you'll notice here the variable is going to be negative. So we want to work with that when we check to see if there's any simplifying. So when I reverse this, when I put the x squared out front, it's a negative x squared and then a positive 4. So we're going to think of this as negative x squared plus 4 in the numerator. And the reason I'm going to do that, you guys know by now, I don't often work with a negative on the first variable, and especially if we're going to do any factoring. So my suggestion is you start off by factoring that negative out so that I no longer have a negative x squared. So if I factor the negative out, negative x squared becomes positive x squared, plus 4 becomes minus 4. My denominator carries through as 2x times x minus 2. Okay, get that written down. And now take a look at it. Look at the numerator. Look what's inside the parentheses. Does x squared minus 4 factor? Should be saying yes. So this negative out front, I'm just going to carry down. X squared minus 4 factors into 2 parentheses. X times x. The square root of 4 is 2, so 2 times 2. And a plus and a minus. My denominator carries along as 2x times x minus 2. And what was the point of doing that? My x minus 2's will cancel. What remains if my factors of x minus 2's cancel? I have a negative on top. I have an x plus 2. And I have a 2x in the denominator. Does anything else cancel? And that's that trick question. There's nothing that cancels. The 2's can't cancel because on top, x plus 2, those are married. They have to be multiplied to be able to cancel. So your final answer here would be negative of x plus 2 all over 2x. It would be equivalent to multiply that negative and say negative x minus 2. Again, it's hard to know what Math Excel would want. Okay, and again, don't forget we need to do our restrictions on the variable. Looks like my picture's a little blurry over there, off to the right, isn't it? Sorry about that. Good news is you have your notes in front of you. Okay, so how do we find restrictions on the variable? We set the denominator equal to 0. And that is anything that was in the denominator, right? So my denominators were, officially you could say the 2x if you want, and x minus 2. So on the x minus 2, you add 2 over, you get 2. The 2x equals 0, divide by 2, and we get x cannot equal 0 or 2. Those are our restrictions on the variable, or what I sometimes call excluded values. They are values that would make my denominator equal 0 and make this problem not possible. Okay, let's try one more of the subtracting. I'm hopeful you're starting to get the idea of things. So as we look at B, do I have a common denominator? No. So what do I need to do to check and try and get that common denominator? Start by making sure everything's factored. X minus 2 is already a factor, so we're okay there. X squared minus 3x plus 2. Does that factor? You guessed it, it does. X squared breaks into x times x. Multiplies to be positive 2, adds to be negative 3. Multiplying to be 2, the only options are 1 times 2. If it multiplies to be positive 2, we need same signs. If it adds to be negative 3, they are both negative. So x minus 1, x minus 2. Okay, so what will be our common denominator? What's in common is the x minus 2. What's left over is the x minus 1. So least common denominator is x minus 2 times x minus 1. On that first fraction, what is my denominator missing? It has the x minus 2. It's missing the x minus 1. So that means I'm multiplying numerator and denominator by x minus 1. How do we multiply x minus 1 times x plus 3? Did I hear the word FOIL out there? I hope so. So x times x is x squared. X times 3 is 3x. Minus 1 times x is minus 1x. 3x minus 1x is plus 2x. And then minus 1 times 3, minus 3. Second fraction. What's missing from my denominator? Nothing. So my numerator just carries down. 6x minus 7. And again, don't forget, what kind of problem is this? Subtraction. You got it. Okay, so denominator. Got my common denominator. X minus 2 times x minus 1. Look for like terms in your numerator. X squared stands alone. No other x squared, so carry the x squared down. 2x goes with 6x. And what are the 2x and 6x doing? They are subtracting. So 2x minus 6x is minus 4x. Okay, my negative 3. What's the negative 3 go with? The negative 7. Now, keep in mind, it's negative 3 minus negative 7. I'll write that out up here if you need it. Negative 3 minus negative 7. I'm going to say keep, change, opposite, So negative 3 minus negative 7 becomes negative 3 plus 7, which is a plus 4. Okay, am I done? You should check and see, does my numerator factor? Is there something it can cancel? So, as we try and factor, my denominator is already x minus 2, x minus 1. My numerator looks like it should factor. X squared breaks into x times x, multiplying to be 4 and adding to be 4 is 2 and 2. If it multiplies to be positive 4, I need the same signs. If it adds to be negatives, they're both negatives. So, do I have any canceling factors? And I do. And x minus 2 cancels, which means it was important that we factored. So once those cancel, we're left with x minus 2 over x minus 1. And again, remember the x's do not cancel because they are not factors. They are just terms. And lastly, don't forget any restrictions on the variable, and that is to set your denominator equal to 0. So what denominators am I setting equal to 0? X minus 2 and x minus 1. We set those equal to 0. Do the math. X cannot equal 1 or 2. And again, yes, notice I did go into C. I'm not going to do C. I figured 2 examples of each, especially when adding and subtracting, is a lot. Okay? And they're lengthy examples, I know. I know this is a stretch for a lot of you. But what I've got to ask is that you keep with me and keep trying to work and figure this out. Okay, one last topic I want to talk about that, and that is complex fractions. You'll notice down at the bottom, there's a definition of complex fractions. Complex fraction is a rational expression that has at least one fraction within the fraction. So this is going to be fractions within fractions, basically. The suggestion here to work with complex fractions, look at all denominators within the problem, multiply the top and bottom of the fraction with their common denominator. What I'm basically going to have you try and do is to get a common denominator on top, a common denominator on bottom, to the point where we have a fraction divided by a fraction, and then we can use our fraction rules. So, let's go ahead over and look at this page. Our first example, and again, I'm just going to try and do 2 examples, get us through some ideas here. 1 over x plus x over y, all over 1 over y plus 1. Okay, so right now focus on the 2 fractions being added on top. If I focus on the 2 fractions being added up top, what would be the common denominator? So if we have a denominator of x and a denominator of y, what kind of common denominator do we have there? That's right, x and y have nothing in common, so x times y is xy. So let's get these so that they have a common denominator of xy. What is my first fraction missing? My first fraction has an x, so it's missing the y. That means we're going to multiply top and bottom by y. 1 times y is 1y. Second fraction, what are we missing? Has a denominator of y, so we're missing the x. Means I'm multiplying top and bottom by x. And the top, x times x is x squared. So we have our common denominator of xy there. Okay, denominator, 1 over y plus 1. And on that plus 1, if it helps, how do you make 1 a fraction? You put it over 1. What would be our common denominator there? 1 times y is y, so we have a common denominator of y. The first fraction already has the y, so 1 over y stays 1 over y. The second fraction, how do you make a 1 become a y? And we're going to multiply by y. If I multiply the denominator by y, multiply the numerator. 1 times y is y, so I have y over y. Okay, so now my job is let's clean this up. On top, add those two fractions together. They already have a common denominator, so common denominator of xy. Add your numerators. Y plus x squared is y plus x squared. Okay, denominator. The denominators have a common denominator of y. So we write the y down, and then 1 plus y is 1 plus y. Okay, the whole point of me getting here is that I now have a fraction divided by a fraction. How do we divide fractions? What you got out there for me? To divide fractions, we keep, change, flip, multiply by the reciprocal. I would be happy with either of those options. So I'm going to write them both down here. Multiply by the reciprocal. Or if you don't like that phrase, keep, change, flip. Those are your options. Or if you have something else that you like better, go for it. I'm going to fix my flip there that I kind of goofed up the L. Okay, so whether you think keep, change, flip, or multiply by the reciprocal, you keep the first fraction. So that means I'm keeping the second fraction. I'm keeping the top fraction. So I'm keeping y plus x squared over xy. I'm changing division to multiplication. And then I am flipping or taking the reciprocal of the second fraction, which is my bottom. So 1 plus y over y becomes y over 1 plus y. And now your job is to look and see, is there anything that can cancel? Okay. The y plus x squared and the 1 plus y, those are not matching factors, so they can't cancel. Look at the xy and the y. Since the xy is x times y, in that case, an x or a y can cancel by itself, which means our y's can actually cancel here. The y in the denominator cancels with the y in the numerator. In the denominator, we have an x left. In the numerator, if nothing else is left, there's a 1. Once you've done all the canceling, multiply the fractions together. Remember, to multiply fractions, you multiply across the top and across the bottom. So when we multiply across the top, y plus x squared times 1 is just going to be y plus x squared. When you multiply across the bottom, I have an x times a 1 plus y. I would be happy if you write it as such, or if you're wanting to, you could also multiply the denominator out. So I would still have y plus x squared in my numerator, and in my denominator, if I multiply, x times 1 is x, plus x times y is xy. Okay. I know these problems are intimidating. They look intimidating. That doesn't mean they have to be. Step 1, we got it, so we had a fraction over a fraction. once you get to having a fraction divide by a fraction, use our how do we divide fractions, and that's when we will multiply by the reciprocal or keep, change, flip. Okay, I want to try B, and then we will call it quits after that, because this is going to be a 45-minute lesson by the time I get done. Okay, I want a fraction over a fraction. So first of all, my numerator is just an x. So how do you make x a fraction? X as a fraction is just x over 1. My denominator, I have denominators of x and y. What is the common denominator if I have denominators of x and y? There's nothing common, so you multiply them together. So x times y gives us a common denominator of xy. On the first fraction in the denominator, it has the x. So what's missing? The y. So we multiply by y, and 1 times y is y. On the second fraction, it has the y. It's missing the x. So we multiply by x. 1 times x is x. Okay. We have our denominators in common. So now, let's get this. So we have fraction divided by fraction. My numerator is already x over 1, so that's just continuing. My denominator, add those fractions. The common denominator is xy. The numerator within that denominator, y plus x, is y plus x. Okay. Can you carry it over from the first problem? Fraction divided by fraction. In order to do a fraction divided by fraction, we're going to keep, change, flip. And I will write that in again. Or you can think multiply by the reciprocal. Whichever phrase makes you happy there. So I'm going to keep my top fraction. So I'm going to keep x over 1. I'm going to change division to multiplication. And I'm going to flip the second fraction, or take the reciprocal. So it becomes xy over y plus x. Okay, home stretch. Is there anything that can cancel? Well, the y plus x can only cancel with another y plus x, which we don't have. So that means that x isn't going anywhere. The xy is diagonal of 1. It can't cancel. So all I can do is multiply here. X times xy. Well, x times x is going to be x squared times the y. The denominator, 1 times y plus x, is y plus x. So I'm expressing my answer as x squared y over y plus x. If you take that denominator and make it x plus y, that would be equivalent as well. Okay. You will see here that your homework is Lesson 8.5 in Math Excel. Period 3, yours is available starting Wednesday, April 8th, and it will be due the following Wednesday, April 15th. Period 6 and 7, your Math Excel assignment, and you can be listening to this video early because it is out there, but your Math Excel assignment will be available Friday morning, April 10th. It will be due the following Friday, April 17th, and all of this information is in Schoology. Okay, give this lesson a try. I'm going to work to get some possible, we can't do Zoom right now, but using either Schoology or this team, Microsoft Office Teams, so we can get some maybe video chats going so that I can try and help you guys. I also do have, with my iPad, I'm able to FaceTime, and so if any of you want to take me up on that and get some individual help, then by all means, shoot me an email and we can get something organized. So Let's finish strong. My goal is to get us through chapter 8 here. I'm going to forego chapter 9 and go with that. Okay, so I hope you guys are getting back into the school groove here for this last month and a half. And I will talk to you guys soon. Bye.